What? Sounds a little cold. Sounds a little cold. Warming up. We have a green light. Yes! Yes! Hey, it's Joel Walsman, CEO and Master Electrician of Jefferson Electric. I'm so excited because we are at the crescendo. This is video number 5. We're at Tom's house. Tom, doctor,
here we go.
We're making wiring connections at the inverter, at the disconnect. Everything's at the ATS. Everything's coming together. The AC module, it's all coming together. This is it. Jump on in, learn with me. This is one of my first times to execute this work, so no poking too much fun, all right? But let's rock. Tom is commissioning the generator right now as we speak.
So Citizens Gas has got 3 different sizes of meters. The most homes, residential homes, have a 250. This one's a 425, and then there's an 800. And 425 is not the actual limit. I don't know what the number is, but they said a 425 can supply up to 617 or so, I think, cubic feet. Is that per minute, CFM, whatever the units are. So the generator itself, under full load, takes 308. The old meter was only 250, so that wasn't going to work. So this guy, which will go up to over 620, will cover the whole house plus the generator under full load. The next size up of that is an 800, which you'll see on commercial stuff, and that can go up to 1.5 million. You like this little design feature? When I put this in, all of a sudden I said, oh, I just boxed myself in, because if you're ever changing this, when you loosen these up, you got to be able to move this back. Well, this is mounted against here; it's not going to move back. So take a look. I got a notch slat in there with long screws. You pull the screws out, and the little notch piece comes out.
Oh my goodness! Right here.
So you see those long screws, you pull the screws out, and that little block that's in there slides out, and that gives you the ability to push the line back far enough to...
Wow. Yeah, so this block, with the removal of these screws,
it slides right out.
That way you've got about 1.5 inches to push it back,
that is
free the fittings, service the unit.
Yeah.
Whoa.
Which plumber did that?
No one ever.
No one. Well, at least I realized it before I poured the concrete. I was like, oh, wait a second, I just boxed myself in here. I got to come up with a solution. You know?
Impressive.
I don't know. If you were doing this yourself, it was your house, would you just cut it to length and just be done, or would you stuff some back in the hole?
I would keep some. Keep some somewhere. And you might have the room to keep it right here.
Yeah, actually, yeah, that's true.
Given the size of the disconnect.
Yeah.
Feel pretty good about that.
Okay.
Okay, so Tom, we're thinking we're going to use this Type B LFNC liquid tight flex. Liquid tight flexible non-metallic conduit, LFNC. We just call it liquid tight. We're gonna have a straight fitting out of here.
Okay.
We're gonna flex and secure above the block here. Wrap around.
Okay.
And I think I'd like to keep enough that, here it is, we can come in. Let's see how much flexibility we have.
First I thought you would maybe come over this way and then in, but.
Come out of the side here?
Well, either out of the side. That's why I left it at this height in case you were coming across here, or coming out the bottom and over. But yeah, because there's a 2.5 hole right there too.
There it is. So got that one and that. Secure low, or just pull that out of there and try high. Okay, Tom and I took a look at multiple ways of installing this liquid tight, and we're going to come in behind this 4x4 post, which will be set in concrete. So from there, straight fitting, LFNC, to a 90-degree fitting on the back side here. will provide one support between connection points. And the reason we're using flexible pipe is because flexibility is needed at the installation. And that's recognized by the National Electrical Code. This thing is going to vibrate a lot, and having the flexibility to absorb those vibrations through the pipe and not through hard joints is an advantage to the longevity of the installation. So I'm in front of the 100 amp NEMA 3R. That's outdoor rating in the code, NEMA 3R disconnect. The ATS, automatic transfer switch, is on the other side of the house. Both power wire and control wire run all the way through the basement. If you're interested in the videos on how we set this all up, click here. So we're now at the load side of the disconnect, ready to terminate conduit and wire into the generator. This is a 24 kilowatt Guardian by Generac. It's beautiful. Most popular brand in America right here. You could head over to the left side of the here. So when you're working with non-metallic liquid tight, let me first say generally the National Electrical Code says conduit systems must be complete before the insertion of wire and cable. Liquid tight is one place I personally make an exception because it has got so many bends and so much resistance. If what we're going to do is pull it out pretty straight here when we shove the wire through, as opposed to having a full 360 degrees of bends fighting us. So here we go. This is going to be so much easier with two people. One to hold it straight, the other one to feed and push, and you can get so much resistance. There it is, boom! Tom, out of curiosity, what are the top 3 considerations that a viewer should make before buying or installing a generator?
First one is whether or not it's going to be whole house or if it's going to be a partial system. And then if it's whole house, what's their needs and what size generator they need to do that. And I guess another big one would be what brand would you go with, but Generac's been the leader in this for a bazillion years, and they have all the market share. And when I was a general contractor a long time ago, had some people that had these for several years and they were very happy with them. So I think that's it, is do you need whole house or do you need partial? What size do you need and what brand are you going to go with? And so, and then I guess also, are you going to go with an automatic transfer switch or some manual situation? So, and they do, you could do manual, but the problem is if you're not home and then power's off and it's something crucial and you don't have anybody to throw it, then what's the point of having the generator?
Yep. One other consideration that I thought was interesting is the gas. Oh. The gas limitation, which is why you put the generator over here, yes, right, as opposed to near the electrical equipment.
So the other key thing is so if you were building a new property and you knew that you were going to put in a generator, when you're locating your utilities, you want your electric meter and your gas to be close to each other. So I forget the exact spec, but we're running a 1-inch gas line to here because this guy pulls 308 under full load, and a 1-inch gas line I think is good up to about 30 feet or so, plus or minus. But if we had this on the other side of the house, which is about 150 feet away, we would have to run a non-stop dedicated 1 1/4-inch gas line under high pressure all the way over there and put a regulator on the other side of the house. And that's not that this was cheap running what we did here. How much was it, Joel, do you think, to run that wires all the way across the house here?
Well, you're probably in the range of about $2 grand. So
they wanted about $2 grand, a little over $2 grand to run gas pipe through the house, but I didn't want high pressure 1 1/4-inch gas line. So what you have to have is you got to have a dedicated, if you're going 150 feet, a dedicated 1 1/4-inch gas line right from the meter all the way over. So I didn't like that idea, having that, and so also I think it's a little easier to run wiring through the house than it is to run that gas all over the place in a finished home. So that's what we did. And now what we've got is, if you look at the meter over there, you'll see that we come right off the meter, and it's so this meter has an 1 1/4 feed, and then you come off of that with 1 inch, and it's dedicated 1 inch is about 10 feet to the generator. So straight on across. Plumber did a nice job with this. I think it looks pretty professional.
Very professional, very sharp.
Real happy with how that came out.
Yeah, that's impressive. It's good to see a professional at work in his craft, right?
Well, I mean, I like to see people take pride in their work, and that's why you're here.
Well, speaking of, I think I'm ready to feed this into the house. I can't shove it, unfortunately, because it's under
you got that? You got
there. So it was a little bit too crowded to keep it all in here. We'll just keep a loop and then shove the rest inside.
Yeah.
Secure it to the ceiling, and that'll give us the ability to splice. You know, sometimes things they go bad. Maybe somebody drills into a pipe. I don't know. And you've got to have a little extra.
Right. Maybe somebody puts a torch on it and burns through the wire. We got to pull some back to splice it.
That's it.
So you got that, is it being held up by some of that like clay stuff that you use or whatever?
Well, actually, I don't see that we've put any duct seal in here yet, so I'd be interested in maybe, Tim, do you want to bounce to the basement with some tape and a staple to secure that up? And then I've got duct
I got tie wraps too.
You got tie wraps, perfect. I've got an SDS Plus rotary hammer, and that configuration right there is SDS Plus bit. You just push and turn, clicks into place, and it's got a ton of hammer action and butters through brick, concrete, even poured concrete. Look at that. Easy, quick. Blow out your hole and your caulk gun. Provide a dab of sealant, which this is a used tube, so I got to cut it back a little bit further to reactivate. Just using it yesterday. There, just a dab. That's all I need, right? Because I'm trying to prevent the infiltration of weather into that hole. Weather is going to cause moisture, specifically, going to cause expansion, contraction, and blowout, and I'm going to lose my grab over time. I'm going to put a mini right there. Using a Tapcon with a 5/16 nut setter, I need to secure my LFN non-metallic conduit, NC, within 12 inches of the box. I'm going to put one right there. And then I've got an exception. I don't have to secure it within 12 inches of the box on the other side because flexibility is required for the installation. So I can go a little bit further. I think the code says 3 feet. That's it! Perfect. Yep, that's good then. All right, the penetration through the house. We put duct seal in there. Duct seal is an electrical product that's in the description. You can buy it about any place. And what it does is it's going to prevent infiltration and the exchange of gases, vapors, bugs, all kinds of things. Whenever you have a penetration through your house like this, I mean, it's literally a 2-inch penetration that's caulked on the outside and duct sealed on the inside. That's probably one of the biggest overlooked components to residential installations. I don't know many or any electrical contractors in the residential market that utilize duct seal. And the reason I say that is because I never see duct seal in a residential installation. But I like it. I love it. I want some more of it. A little workmanship tidbit. I'm putting my anchors at the same height, same elevation with reference to the brick, because that's my visual reference point. And then I'll probably have them in the same orientation, but this does need a wider bending radius, so we'll see if I can actually accomplish that. Look at that. Okay, a little adjustment required here. Back it off. Flare it open. Popped out. Slip it in and back in action. There it is. There it is. These are 1/4-20 bolts here. These are the building block of the many industries. Electrical industry, non-exempt. 1/4-inch diameter, 20 threads per inch. I know I'm using my channel locks backwards, guys. Ugh. You know you'll get a ton better grab here if you go like that, but my range of motion is harder to be low, so I'm gonna grab it backwards because I don't have a lot of resistance. I'm not trying to get this super tight. You never put a fastener on a pipe that's gonna deform the diameter or the shape of the pipe. That's a code violation. You just want it to be secure, not death grip.
So what gauge wire is this that we're running then?
Let's see. That's a good question.
Big enough, right?
Right. That's this is 2 gauge.
Okay.
Which is rated for 100 amps.
Okay.
As residential feeder and service conductors.
Okay.
And this wire we intentionally upsized because that was the length of the run where we were going to experience most of our voltage drop. Thanks. Okay. All right, let's get our wire in this or wire in this pipe, which probably means one more fitting there. First, all right, I think, let's see, do a fitting, cut to length. I'm gonna cut a little bit off that, another 2-3 inches. This LF&C is pretty lightweight. You can just take a brand new razor blade and of course you could use a sawzall, bandsaw, hacksaw, cut that. Razor blade works. So that's gonna be right in there. All right, 2 more pipe supports before we're off and running, because I want these supports to be within 12 inches of the box, and then these 2 supports to be within 3 feet of the fittings. Now we're putting another mini on the bottom conduit. This is the last one. Finish pulling our wire and make our connections and terminations and move on to page 2 of the installation guide. Hey, if you need an installation guide, check the description. There's a lot of helpful information condensed in an easily digestible format, courtesy of none other than Double T. So this is a Polaris slug. This comes in all kinds of configurations for all kinds of wire, 14 gauge and up. I'm not aware of any smaller than that. It's my favorite kind of connector. It's very high value with respect to labor savings, and labor is what you're trying to save in the trades. If you're a DIYer, you might use a split bolt. It's gonna be a lower cost connector, but it's gonna take you more time. So this Polaris slug, beautiful. At this point, I want my neutral to be floating and not bonded to the cabinet. This generator is not a separately derived system. It could be under some circumstances, but we're gonna pop over to the automatic transfer switch and show you that the grounded conductor, the neutral grounded conductor as opposed to the grounding conductor, is continuous with a firm or fixed connection from the utility to the premises wiring system. If that was a floating connection through the windings of a transformer, for instance, then this would be a separately derived system, and we'd have to drive ground rods here. And that is one of the confusing aspects of the code, all this whole talk about that kind of stuff. But if you check the description, my buddy Ryan Jackson's channel, he's also very smart. He's probably almost as smart as Tom is. But Ryan doesn't know that he's my buddy, but I'm his buddy. I have met him in person, really down-to-earth individual, and he's got great videos that are absolutely tremendously boring. Unless you're an electrician and you make your livelihood on the electrical industry, and people's homes, businesses, and safety are literally dependent on your hands and your head. Then Ryan Jackson's stuff is pure gold. So check out the description and check out Ryan Jackson. You've got it. If you're a pro, you've got to sub to that channel. You've got to. If you're advancing your trade, your knowledge, your career, got to. All right, so you'll notice I added an additional lug for the copper grounding conductor, and that's because that's not a 2-conductor rated lug, and it's got an aluminum wire already terminated in. So I didn't want to have 2 dissimilar metals, so I backed that out. I've got 1 lay-in lug, because it's got the opening on the side for my grounding conductor, that's copper, and 1 for the aluminum, and they're bonded at this point here to the equipment cabinet. So now my exterior disconnect is complete, and I'm ready to close it up so I don't hit my head in the meantime. All right, let's terminate wires at the unit. This will be fun.
Extra light, I've got.
Oh, look at that. Why not?
I don't know where that came from.
So Tom, you've purchased a separate kit, which is a battery heater kit, right?
Yep,
battery heater. That's a heating pad?
Yep, and a heating pad there, and the other side of it is an oil heater over here. So it wraps around the...
I see it.
Wraps around there.
So it keeps the oil from congealing and the battery from freezing.
Yeah, so the winterization kit needs 240 volts. These are the AC terminations. Oops, AC terminations over here. So the T1, T2 are the, is that right?
N1, N2?
I'm sorry, N1, N2 are the sensing wires that are bringing 240 volts off of the main service. So they come in here, and then there's 2 connectors on each one. So the control wire is going to bring 120 volts in on each side, and then these guys are basically connected to that, so there's basically 240 across that. So basically 240 feeding the battery heater and then the oil heater. Both of them have a sensor in them, and when it's below 32 degrees, then they will feed 240 volts into the battery heater, which is a pad that the battery sits on, and then to the oil heater over there. Nice. And again, they're picking it up right off of those connections, which are spring-loaded, just like this. You push in and slide them in. If you don't push in all the way, you're going to be frustrated.
It's beautiful. And we've got the right light for the job.
Okay.
Well, I'm going to start leaning our power conductors here. Tom's going to be prepping our soldering iron. Yeah, there it is, heating up, heating up.
A little bit.
Our soldering iron for tinning the ends of these control leads, and that's just going to help us get all the individual strands into the terminal without having those be pushed out aside. Essentially, it's the quality of the connection. You have to remember, Tom is trained as an electrical engineer. Okay. So one of the things I'm going to be doing here, you see, I could pull that tight as a piano string, cut it and terminate it, but I've got zero forgiveness. So what I'm actually going to do is I'm going to push it back into this electrical wiring compartment, and I'm going to cut it right there. And I'm going to leave myself a little bit of grace and mercy. If you're watching this and you don't know how to solder, soldering is one of the easiest skills to pick up. One of the tricks is get it nice and hot.
Right.
When it's nice and hot, you get a good, clean, clear connection.
Put it on this
and
side.
The brightness of the connection is indication that it's a quality connection. When it's real dull, then you probably weren't using enough heat.
Okay.
You've had this longer than you've had Linda, huh?
Yes.
Okay, well, is she jealous or are we okay?
No, we're okay.
We're okay.
We're gonna need recolor, but see, we're probably gonna have to cut 3 of them short. See, because 3 of them start here, and then the other 3 go over to here. So the AC ones stop there. So we may be retinning. You might want to cut 3 of them back a little ways when we get to that point.
See it.
I'll leave the soldering iron nice and hot, so we can come back and do a do-over if we need to. The tie wraps they have the 3 120 volt lines, the 2 cents and the other one going through the top tie wrap, and then they show the the DC lines going through the lower one.
Okay.
Yeah. As you said, your power conductors come straight in. It's just what they show on the control wires. They show the 3 that are carrying high voltage going through the top, and then the 3 that are carrying low voltage DC going through the bottom one.
Okay.
What would you say is best practice here, since we're taking a control wire? Do you cover the whole thing, or do you let it show through that it's brown so somebody can see on the other side?
I like that, yeah.
Okay, so I'll do a couple strips of it.
Provides a little bit more information. Let me see what it looks like here.
Okay.
And the DC, the number 1 terminal, is that black?
Don't they have them color coded? Yes, they do. Let me grab my
I
pusher thing here if you want to see. Where's my little tool ready to go?
And that went right in beautifully.
Oh, did you already push it?
Uh-huh.
Oh.
Yep. Oh, happy to, yep. This is an even better one. This is one of the best screwdrivers you'll ever buy right here. 1000-volt insulated Kleins with interchangeable tips, and Tom has got one, and it is beautiful.
I read about that on some website. I think it's Electric Pro Academy.
Oh, huh. Never heard of them.
Okay.
All right. Little tug test, always. You want to get the right strip length, because the last thing you want is some of that insulation underneath your terminal, and so we've been real conscious of that. Looks good. And now let's just see what this looks like and see if we want to make some varying strip length. Our color coding is here. The last thing we want is something that's going to keep Tom up at night out here.
Yeah.
Let's see.
So one's yellow and one's yellow with black. See?
N1 and N2.
Yep.
And which one is yellow?
Here. Yellow with black is 2.
2. There it is. Okay, I see the way they've got it marked. It's subtle when it's a black stripe. There it is. Oh, yeah. Man, when you've got a sharp guy like Tom that lays all this stuff out for you and it's just ready to go, it's not too hard. It's really not too hard, but the trick is in the prep, right?
And then do a little tug test and tug test on my other 2 wires here that they didn't come loose because we loosened those. Oh, that one's low.
There's the tug test, folks. We have it. Okay. No.
Awesome.
Come on. All right, I'm pulling on the conductors individually.
They're soldered together.
Nice. And that one's good. And that's good. And let's check this here. And that there. Okay. All right.
Okay.
Seems a little further out than the zone, so I'm just going to play with it one more time.
Okay.
And that is even a bit better.
Okay. Yeah.
Okay.
I was only pushing halfway. So if you are doing this yourself, I mean, anyhow, if you're doing this, it's kind of like a first level and a second level push. And if you only go part way, you're not all the way open. And I fooled myself for quite a while. I was like, why is this not gripping very well?
Okay, I like that. We've got some extra conductor in there. Okay. I don't know that we'll ever need it, but you just never know sometimes. Yep. And then this looks good. Everything's been tug tested. Our terminals are right. Ooh. Oh, that's just the heat shrink that's sliding.
Oh, heat shrink, yeah. Yep.
Okay. Tom, what do you think?
Oh.
Look at that. Snappy doodle. It's interesting. Because you heard it snap when it popped out.
Yeah.
I wonder.
Maybe because it's sharing the wire with another spot. I don't know.
Yeah. I wonder if they're affecting each other. All right, let's try this. Maybe it was just right on the end because that time it's staying under good pressure, but now this one's coming out. Hopefully they're not mutually exclusive here.
Right, I understand what you're saying by that.
Okay, that's staying. That is staying. Okay.
In worst case,
get your fingers in there again. Feel that.
Okay. Worst case scenario, I'd come back and I would solder them together and just use one feed. Because electrical engineer. Okay. Okay, that's good. This is the regulator. This is the regulator for that. And so this is the gas valve right here. So where that manometer port is on the north side of the pot, so you see that's gas coming out. That's just gripper stuff I had there.
Smell that?
But if I'd put that on the bottom, you wouldn't have anything coming out right now because the valve, this valve is closed right now. It's not turning gas on to the rest of the thing. So that makes sense? So this is the goes into, and that's the goes out to, and from the goes out to the.
I love it. This guy knows it all. Let's keep rolling. What's the next step, Doctor?
All right. So we're going to go over to the ATS. Let's put this battery back in here. Did I get it all dirty?
I've been sitting on my legs way too long.
Yep. So this guy goes back on the pad.
Blood flow.
No battery comes with it. They give you a spec and you go out and buy one. Interestingly, it was not as easy as I thought to find a 26R, which is what it calls for, but they had them at Sam's Club. Okay, I want to get somebody slide that like right underneath while I'm holding it. Maybe if I get it. There it is. Okay, and I'll show you up here the fuse. The very last step, so let's not lose this because that's the port for the gas. And put this guy back on here for now so we don't accidentally just start sending gas out into the wild blue yonder. Okay, and so there is a fuse right here, under here, and right now that fuse is out.
Okay.
And it stays out for now.
Pull the fuse out.
Yep. Okay. They got a prescribed.
Breaker's off inside here.
Yep.
That's. Know there's another disconnect.
Yep. And then there's two emergencies that'll screw you up too. There's one shut off here, and there's another shut off right over here. So that's if the firemen come here and you didn't have that switch, and the generator is running, they want to shut it off. They can shut it off back over here.
Great.
It's not a nice shutdown, and they say don't do that unless it's an emergency.
It's like cramming your brakes on the interstate when you're going 75.
Yep.
The rain is falling this afternoon. We've had some modest shelter underneath the canopy. The doctor is hard at work running the tests. We're in the commissioning process. I've got to bring one thing to your attention, that this video is sponsored by, you guessed it, Span, my favorite smart home electrical panel. See, Span is beautiful and simple, and now I'm so excited to say it's also generator compatible. Span must be placed downstream of an automatic or a manual transfer switch. It will see the generator power as grid power, and it will give you the intelligence in the palm of your hand on any mobile platform to monitor your circuits and control and select and manage your current flow in the house, your loads, your circuits, so that if you've got a limitation in your gas line, your generator supply availability, whatever the limitation of your situation may be, SPAN allows you to manage your power to accomplish your energy independence goals. Be resilient, choose SPAN, check the description, let's get back to work. We are now on the other side of the house.
160 feet away.
160 feet, who's counting? And it's time to make terminations. So we've got, I'm gonna use a knife for that. Get that out of there.
This is 600 volt rated, and it's just going to be basically normally closed. It lets the air conditioners run, but if the module decides that the needs to shed some load, then what does it opens up this connection, which is in series with your control wire for the air conditioner, and so basically it tells you inside or goes to that.
No, is there a polarity between 1 and 2?
Nope.
Interchangeable, okay.
Yep.
And so if you're a plumber and you hear normally closed, you're thinking no flow. Electricians and plumbers were opposites, right? So normally closed means connected. Connectivity, conductivity, current flow. Okay, now we've got 1, 2, 3, 4, 5, 6. The other 6 are all landing on this terminal bar here.
Yep.
Yes, sir. Yes,
Top
sir.
three.
Okay, let's pull out the good old DMN.
Now let's go with the 2 cents ones first, and 1 and then 2.
Oh, look at that fuse installer. Let's get that baby in action.
I'll get you out of there. Okay, one more. One more.
Yeah, that's the only other way to do that is with a pair of needle nose pliers, and you might just blow it out, that little glass tube.
Yeah, it comes with this little fuse installer.
Comes with.
Yep,
Nice.
it's got a little mounting spot for it right under here.
Good
Okay,
job,
so now
Generac.
we should see we should see from neutral, we should see on N1 and N2, we should see 120.
Yep.
Okay.
Yep.
Okay, and you should have 240 across the two of them, which you can see on
Okay.
the other side. Just don't touch them together. Okay.
Yep.
We should have nothing right now on T1.
Okay.
Put the fuse in.
0.
Okay. All right. Now let's put a fuse in, and you should have 120 to neutral there. Oops. In all the way. Nope. Pull you back out. Okay. All right. Now we should have T1 to ground. We should have 120.
Boom.
Okay, now let's go to the other side.
So Tom, what are you putting on that battery terminal there?
Lithium grease, because it should inhibit rust, similar to what Nolox does for your aluminum stuff, right?
Mm-hmm. That's it. Man, a true professional DIYer. Is there such a thing?
I guess. Also,
Prosumer.
instructions
Has got
say
a
to do
whole
it too.
Cabinet full of this various compounds for various applications.
Yes, sir.
You've got your pipe dope, you've got your water dope, you've got your Nolox, you've got your white lithium grease, your WD-40, your Corrosion X, your contact cleaner here.
Yep.
The list goes on and on and on. All right, the instructions do say red battery terminal first.
That's what you always recommend in a car too. Okay, there we go. Put the black one on. Maybe lights will change status.
Nice, look at that. He just lays them right in there. Good wire management.
Oh no, they won't change until I put that fuse on, right? Let's put you over there, I guess, so I can get on there.
Would
be nice if
in a rug. You want me to pull the battery out for you?
Yeah, there we go. How about that? That's a
Okay.
paradigm
Drop
shift.
that handle back.
There we go.
Nice, clean, greased, snugged, but not strips. Wiring connections, just beautiful.
Okay, and then we want to set it. Wait, we want to try and maintain the position on the heat pad underneath there. There, pull you back up there.
Okay, all right. Mm-hmm.
Almost. Okay, all right. Set you back over here. Just the gas, yeah.
Whoa,
Okay.
there goes. What, folks? Live gas.
Live gas. We should have.
Any rotten eggs? Nothing yet?
No. There's our reading. According to the manual, it says 3.5 to something like 6. What we got, 4.3 or something like that now? Okay. Install the red battery plus.
Want it.
Okay. All right, here's my thing.
The question, looks like our inside scale is inches of water, and we're at 7.2.
Oh, 6.6. Oh, inches of water is in it. Oh, awesome. What's it say here? 5 to 7. All right, we're just above 7. Okay, so it's not 4.
Okay.
Boom, baby. We got plenty. Got plenty. Okay, so the next step, I think, is to put in the fuse, which should light up stuff up on top. Okay. Whew.
Jittery with excitement.
Connect battery. Reinsert 7.5 fuse up here.
All
Oh, it
right.
says language on here now, too.
Oh, time to make our selections. Chinese, huh?
Yeah.
We'll never get it back off that way if we do. Here goes the fuse.
Is it? It's not in the right. So you can see better. There we go.
Any fine operations
Fuse.
going on here.
Okay.
Yeah, baby! This thing's cranking! What? We did it! Click here for our next video. This one not on generator power, but solar energy powered. And it didn't all go right. And subscribe to Electric Pro Academy for real skills to make real money.